for the user to both coordinate using computer and also giving, like in this case, giving a presentation at the same time. If I would have to paste the slides, I would have to actually stand there and actually press the button. And it would be much easier if with some sort of device that allows users to just stand someplace away from the computer and just use some sort of mouse input or something like that, and that will actually be able to move slides. Yes. Devices like these do exist, such as Logitech Air mouses and products from other vendors. But often these require purchase by additional hardware. And well, that itself is something that a large project will solve. So, let me show you the setup for a project. It will basically consist of a projector, a computer, and a camera. So basically, the camera will always be receiving input from the projector screen, and we'll have software algorithms on running on a computer to actually process the image. So, in the end, the user will be able to actually use the actual laser point itself and act as an actual mouse cursor. So, like this, if this is such as a Windows GUI, Windows desktop, I can basically move my laser point around and I can have a mouse cursor follow it. And of course, if I want to put clicks and different clicks, such as different single clicks, I can do that and suggest use of a single laser pointer. This is the main system block diagram for our system. So this includes also the other physical setup, as included with the network camera itself and also the projector. You see, they're all connected to the projector screen. And in the end, we have the mouse output that displays information back up to the projector screen. That will actually help move the actual mouse cursor around. The computer session will be extended to the camera. So this is the computer system of our system. So the main components you can see here are the image acquisition part, calibration part, image detection, current correction, and mouse driver. So each one of these are basically considered one of the main tasks. Like most of us have one of these tasks that work on specifically. So the actual process is as follows. Images from the actual network camera come in and will be acquired through our image acquisition system. It will be a series of JPEG images and we acquire those. For the first use, it'll go through this path here. It'll go through a calibration system, which it will actually isolate the actual projector screen from the rest of the actual image itself. And later on, when everything's off, later on, it'll also create a transformation array. They'll basically map distorted coordinates onto ones that are correct. So basically, when everything is all done, set, you'll actually be processing through this path, in which images will come in, images will be detected, coordinate values will be mapped accordingly, and all the detected values will be going on to the mouse driver itself, which will later on use the mouse cursor and process the corresponding mouse cursor. These are our main requirement specifications. First one is, of course, a laser pointer. We require at least a class 3 laser and 5 minimal output, such as something like this one. So it'll work identify enough. Of course, it also work under inclement lighting or clicking lighting, so under direct light. Environment lighting conditions. It was specified by our customer appliance itself that our project must work both in the room with lights off and also with lights on. Right. As for accuracy issues, we require that in order to ensure accurate splits, we require that the mouse cursor itself and the laser point will not be greater than 12 pixels apart. And for your actual personal computer usage, we just standardize the most modern day computer, so specs and of course with Windows operating systems, that's what this is commonly used. And it also support and require most of the physical areas like and other application protocols. We're using the Access 206 network camera because this is specified by the customer what to use. In order for this system to receive like you can say real-time feeling, we have a requirement that says we must deliver at least 20 frames per second images coming in. And of course, the network camera itself must be able to see all the projector screen in order to perform all the images. So this is why we also have a requirement of having the network camera not face any more than 30 degrees from Earth. And of course, this being a network camera, we're also going to have network bandwidth issues. Slow networks will affect our project itself. So that's why it's very important. And so that's why we have the requirement of having at least available 5 megabytes, free available bandwidth for the project to use. And for Exit itself, it's not provided, so that they're actually saturating providing. So we have the requirement of having at least 1,000 to 2,000 max and limits of that limit filter if you actually do technical Exit system. Now, the following slides will go into more detail about the different modules.
So now we get into the actual implementation, how things work. It's important to note as we move into this that the project was developed entirely in C# using Microsoft Visual Studio. We don't get into the code, but this is generally the process that the software goes through to perform the required calculations. The first step here is acquiring images. We have down here what a typical image might look like from the network camera. It sends these guys out. These images are each 640 by 480 VGA pictures, and you can see the image quality is okay. It sends these images out to anybody who requests them, and the software is able to hook up to the camera and download these at as fast a rate as it's able. Once it's downloaded, the JPEG image off of the camera, which are incidentally stored in a little server on the camera, it then takes the JPEG data and converts into a bitmap object, which it then converts again into a byte array, which we use to perform all of our calculations. That byte array contains all the information about the various colors of the pixels and their positions. We go through the extra step of converting it into a bitmap, since we need a great number of these images at a very fast rate, and transmitting them via or downloading them as JPEGs is the only way to get as many as we need in as short a span as we need. The bandwidth gets very large very quickly. Once we've got an image, we can play around for a little bit. The first thing we need to do is figure out where on the image the screen is. I'm going to go back to this slide for just a moment to show you that out of an entire image, we're only interested in this portion, this screen portion. So we need to find out where that is. We do that using an auto-calibration system. What we do is we mark the edges of the screen, or more accurately, the corners of the screen, with flashing colored blocks, which the computer, or the camera can see, and which the system will download and interpret. It downloads 10 of these, in fact, and inspects each one of them, comparing one to the last to look for changes in color. Those areas where it sees the most change, it can assume are the corners, or at least these corner blocks. Once we have identified all of the corner blocks, we're able to find their most extreme points, which are the very most corners of the image. Now, why do we need this, you say? Because once we've got the 4 corners of this thing, we can run a projective transformation, word I can never remember, on the that set of coordinates to transform this corner, this corner, this corner, this corner into this corner, this corner, this corner, this corner. So that's going to take this projected screen image, turn it around, expand it, rotate it, and turn it into something that represents whose coordinate system matches an actual computer screen. Once we've done that, once we've calculated that transformation, we actually run through and fill a 640 by 480 array with a set of points that correspond to the correctly mapped pixel locations that would appear on the actual computer screen. So if you call in the index of a raw coordinate, like if you call in like this guy right here, who's probably like 200 by 400, that array address will be 0, 480, since it's the lower left-hand corner. And